Okay, guys, I want to go over powers, exponents, and how to simplify exponents for our quiz. The first thing, let's make sure we know how to evaluate. And remember, we're not going to be using a calculator. So for our first problem, our base is -6, and it's raised to the third power. So this means that we need to expand the negative as well as the 6. So we know -6 times -6 is positive 36. Times -6, and then we're going to get a negative, and then we'll just calculate this. And so we have 36 times 6, and we get a -216. Our next problem, the exponent is 4, the base is 10. Negative is not part of the base, so you do not expand the negative. So then we have 10 times 10 times 10 times 10. We're going to have a negative answer, and then we get 10 times 10, and another 10 times 10, and so we have 100 times 100. So we get -10,000. Our next problem, our base is 7. The negative is not part of the 7, is not part of the base, so we only expand the 7, and we have the negative out front, and we get -49. Our last problem, the -5 is your base, so the negative is part of the base. And then we're going to multiply. Again, I like to pair up factors, and we get +25 times +25, which gives us a total of +625. Okay, now let's make sure we know how to write exponential expressions. So sometimes we need parentheses and sometimes we do not. So here we have 3 times 3 times 3 and then x times x. So we have to write these separately because we have 3 3's and only 2 x's. So that's how we would write that. The next problem, there are 2 different ways and you need to be able to identify both ways. So I have 2y times 2y times 2y times 2y. So my base, the way it's written here, is 2y. And we need parentheses, and we have it raised to the 4th. Or you could say we have 1, 2, 3, 4 2's being multiplied and 4y. So you could separate it. What you cannot do is say 2y to the 4th. This would be 2 and then 4 y's, and we're missing the other 2's. The way, if you write it this way, the exponent is only going to the y, so that is not the right answer. Our next one, -8 is what's being expanded, so -8 is the base, and we have to use parentheses, and then we raise it to the power of 3. If you wrote -8 to the 3rd, that is not the same as -8 to the 3rd. So don't write it this way. Our last one, 7 is what's being expanded. The negative is not part of the base, so you do not need parentheses. So that is your answer. Now let's go through these and apply the 0 rule. The 0 rule says that we have the base divided by itself, which always gives us 1, unless there's a negative. So here, this is 9 over 9, and it's +1. In this case, this 0 is only applied to the 9 and not the negative, so we have -1. In this next example, the 0 is applied to both the negative and the 9, giving us +1. On this example, the fraction doesn't have parentheses, so the 0 is only applied to the 2, and this 3 has its own little exponent of 1. So 2 to the 0 is 1, and 3 to the 1 is 3. However, on this problem, 2/3 is raised to the 0. The 2 and the 3, everything's raised to the 0, so we get 1. This example, the negative is also raised to the 0, so -2/3, this whole thing is raised to the 0, so we have a +1. A to the 0 is 1. We have negative a to the 0. The 0 is only applied to the a, so we have the negative, and we have 1. In this case, the negative a is the base, so it's negative a divided by itself, giving us a positive 1. In this example, oh, this is exactly like the last one. I think what I meant to do is we were supposed to have AB. I think this needed to have, so let's do this. Let's put, this should be negative AB raised to the 0, and we're going to get positive 1. Here we have A, B to the 0. Now guys, this 0 is only attached to the B, so I still have A times, and then B to the 0 is 1, and we really can just write A. And here we have AB to the 0, where A and B is both raised to the power of 0, so we get 1. Now let's talk about the negative rule. So here, anytime you have a negative exponent, I'm not talking about the base being negative, just the negative exponent, you have to flip it down to the opposite location, and then we make it positive. So let's go through these. 5 to the negative 2, the negative on the 2 says I need to make a fraction, and then we know that 5 times 5 is 25, so we get 1 over 25. In this example, the negative exponent is in the denominator, so we have to flip this to the top, making it positive, and we know 2 to the 4th is 16. In this example, there are no numbers to evaluate. All we have to go through, and nothing's the same. We have all different factors, so nothing to combine. So we're just moving factors. So the b to the negative 1 goes to the denominator, becoming b to the positive 1. Now we're in the denominator. A squared is positive, so it's going to stay where it is. But c to the negative 3 wants to flip to the top and become positive. So in the end, this is how I would write it. Okay, now we're going to apply the product rule, and what we're doing is simplifying. So if you have two bases that are the same and the operation is multiply, you write the base, so you're not multiplying anything, you write the base and you add the exponents. Then you just have one single factor instead of two separate ones. So here our base is C, and then we're going to add 5 plus 3. In this example, our base is M, and we're going to add, and we get negative 2, and we have to modify and put it to the denominator. In this example, we have a base of Z, and negative 4 is our new exponent, and then we have to make it into a fraction. On the next one, we just simply have 2 times 3, which is 6. Then we have a base of A, and we add exponents, and we get 8. Our next one, we have 4 times 2, which is 8. Our base is B, and we're going to add exponents, and we get 0. B to the 0 is 1, and then just 1 times 8 is just 8. In this example, we multiply and get negative 6. Then we have k squared times k to the negative 5th. The rule says to write the base and add exponents, and we get negative 3. Now this negative 3 is only attached to the k, so negative 6 stays in the numerator because it has a positive exponent, the understood 1, and the k comes down to the denominator and becomes a positive 3. Now the quotient rule says if you are dividing bases that are the same, the way we can make it into a single factor is subtract the top exponent minus the bottom. So here we have our base is x, so you just write it, and then we say 7 minus 3, and that gives us 4. On our next problem, we have k to the negative 4th divided by k squared, so our base is k, and then we subtract -4 minus 2, keep, change, change, and we get -6. Now, since our exponent's negative, we have to turn it into a fraction. On this next one, let's talk about just the number. So 12 divided by 3 is 4, and then we have a base of a, so I just go ahead and write that down. And then I say 3 minus 5, and that's going to be -2. So the 4 stays where it is, and we put the a to the -2 in the denominator and make it positive. The next one, we are going to look at the 18 over 24, and we can divide 6 into both the 18. So we're going to have 3 over 4, and then we have a base of w. So just write it down. Now don't be moving this -3 to the top and all that. We're just going to apply the rule, and then we'll move it if we need to. We may not need to. It may end up being a positive. So here we have 5 minus -3, keep, change, change, and we get +8. So we don't have to move it. So it's going to stay at the top with the 3. And that's the quotient rule. I hope this helps.